Imagine holding a simple bar magnet in the absolute silence of deep space, millions of miles from the nearest star. While it might seem like a static, unchanging object in that vast void, the moment you set it in motion, you aren't just moving a piece of metal. You are initiating a complex electromagnetic performance that ripples across the cosmos. When that magnet is stationary, its influence is predictable and localized, creating what physicists call a space-varying field. But the second you give it a push or a toss, you fundamentally change the physics of the entire scene. You have transitioned from a static environment to a dynamic one, creating a time-varying magnetic field at every single fixed point in the surrounding vacuum. The magnetic environment is no longer constant. It is now in a state of continuous, energetic flux. This is where the true magic of Maxwell's equations takes center stage. According to Faraday's law of induction, a shifting magnetic field doesn't just stay magnetic. It actually induces an electric field in the empty space around it. This isn't just a theoretical concept or a mathematical trick. It is a tangible, invisible companion that is birthed by the magnet's motion. This electric field follows the magnet through the dark, effectively turning your simple physical movement into a traveling wave of electromagnetic energy. And space itself, despite how it looks to the naked eye, is far from a perfect, empty nothingness. It is a vast, invisible landscape filled with low-density plasma, high-speed solar winds, and colossal planetary magnetic fields. As your magnet travels through this high-energy environment, it begins to interact with its surroundings in ways that feel almost like friction. The magnet can induce tiny electrical currents in the metallic hulls of nearby satellites or clash directly with the charged particles streaming from the sun. These interactions create a phenomenon known as magnetic braking, a ghost-like drag that physically resists the magnet's motion. It's as if the magnet is trying to swim through a thick, invisible fluid that saps its momentum and slows it down. If you were to take this a step further and set that magnet spinning rapidly as it drifted, the stakes would become even higher. That alternating, rotating field would begin to launch actual electromagnetic radiation out into the distance, essentially broadcasting a signal of pure energy into the void. This radiation is not free. It carries away the magnet's own kinetic energy bit by bit, radiating it out toward the furthest reaches of the universe. In the profound and chilling isolation of a vacuum, a spinning magnet wouldn't just spin forever like a perfect perpetual motion machine. It would continue to bleed its energy into the cosmos, one wave at a time. Slowly, inevitably, the rotation would weaken, and the magnet would grind to a silent, motionless halt.